and share and subscribe and like.
This new video we will discuss another important integration of algebraic function. This is again an irrational integration. It is of the type x raised to a m into a plus b x raised to n whole raised to p into dx, where the m, n and p are not necessarily integers. Now it falls into three cases. Suppose consider the first case. In this case, suppose this p is integer. P is integer. If p is integer, then expand this term. Expand a plus b x raised to n whole raised to p by binomial theorem. By binomial theorem, and integrate this. Then multiply this expanded term by x raised to m and integrate term by term. So this is the very first case when the p is integer. Now second case, if p is not integer, or m plus 1 divided by n is integer, is an integer. If this is an integer and p is of the type r divided by s, then in this case we have to put a plus b x raised to n is equal to u raised to s, and then the integral will be converted into s divided by bn into integration of u raised to s minus a divided by p whole raised to k into u raised to p plus s minus 1 into du. Okay, so if here this k is positive, first consider if k is positive. If k is positive, again apply binomial theorem to expand this and multiply by this u raised to p plus s minus 1. If k is negative, then application of binomial theorem. If k is a negative, apply method of partial fraction. And third case of this type of integration is when p plus m plus 1 divided by n is an integer. If this is an integer, then in such a type of integer, put x equal to 1 by 2. If we put x equal to 1 by 2, the integration will be converted into minus integration of t raised to minus m plus n p plus 1 into b plus a t raised to n whole raised to p into dt. Now in this case, if minus m, here is minus m, not bracket, okay. So if minus m plus np plus 1 and divided by n is integer, then the above integral will be converted, or we can apply the case of case second to evaluate this integration. So these are the three cases which this integration is basically converted into. So first case is a very easy. If p is an integer, then apply binomial theorem, expand the bracket term and multiply by x raised to m, and that will be easily integrable. If p is not an integer, that means if p is an rational number, it is of the type r divided by s, where r and s are integers, but m plus 1 divided by n is an integer, then directly substitute a plus b x raised to n equal to u raised to s. This will gives us again two cases, if k is positive and k is negative. If k is a positive, then apply binomial theorem. If k is a negative, then apply partial fraction method. And third case is if p plus m plus 1 divided by n is an integer, then we have to put x is equal to 1 by 2. So these are the three cases. To clear this, let us take an example. Suppose we want to integration of x raised to 1 divided by 2 into 1 plus x raised to 3 divided by 4 whole cube into dx. Okay, now compare this with x raised to m a plus b x raised to n whole raised to p into dx. Then you can see that we have m equal to 1 by 2, n equal to 3 by 4, and p is equal to 3. The very first case is applicable. P is integer. P is an integer. Okay. If p is an integer, then expand this by binomial theorem. Okay. X raised to 1 by 2 into integration of 1 plus x raised to 3 by 4 whole cube into dx equal to integration of x raised to 1 by 2 into expansion of this first term plus 3 into x raised to 3 by 4 plus 3 into x raised to 3 by 4 whole square, that is 3 by 2, plus x raised to whole cube, that is 9 divided by 4 into dx equal to, now multiplication, first term is x raised to 1 by 2 plus 3 into x raised to 3 by 4 plus 1 by 2, that is 2 by 4 plus 3 by 4 plus 3 into x raised to 1 by 2 plus 3 by 2 plus x raised to 2 divided by 4 plus 9 divided by 4 into dx. Okay, equal to integration of x raised to 1 by 2 plus 3 into x raised to 5 divided by 4 plus 3 into x raised to 4 by 2, that is 2 plus x raised to 11 divided by 4. Now this is easily integrable. Integration of x raised to 1 by 2 is x raised to 3 by 2 divided by 3 by 2 plus 3 into x raised to 5 by 4 plus 1, 5 by 4 plus 1, that is 9 divided by 4 divided by 9 by 4 plus 3 into x cube divided by 3 plus x raised to 11 by 4 plus 1, that is 15 divided by 4, 15 divided by 4 equal to 2 divided by 3 x raised to 3 by 2, this 3 will be cancelled, plus 4 divided by 3 x raised to 9 by 4, 3 cancel, plus x cube plus 4 divided by 15 into x raised to 15 divided by 4. So this is the case how we can apply the first case of the irrational integration algebraic expression. Now let us consider the integration x cube into 2 plus x raised to 4 whole raised to 2 by 3 into dx. So let us compare this with x raised to m plus into a plus b x raised to n whole raised to p into dx. We get here m equal to 3, n equal to 4, and p equal to 2 divided by 3. Then m plus 1 divided by n equal to 3 plus 1 divided by 4 equal to 1. So an integer. P is not integer, and therefore we move to second case. P is not integer, so, and in this case we have to put here what is the substitution, a plus b x raised to n equal to u raised to s. What is u raised to s? P is equal to r divided by s. Hence we put here 2 plus x raised to 4 equal to u cube, and then you can see that here this is a 4x cube into dx is equal to 3u square into du, or x cube into dx equal to 3 divided by 4 u square into du. So therefore integration of x cube into 2 plus x raised to 4 whole raised to 2 by 3 into dx equal to integration of x, this 2 plus 4 2 plus x raised to 4 u cube whole raised to 2 by 3 into x cube into dx 3 divided by 4 u square into du equal to 3 get cancelled. 3 divided by 4 integration of u square into du equal to 3 divided by 4 integration of u raised to 4 into du equal to 3 divided by 4 into u raised to 5 divided by 5 equal to 3 divided by 20. And what is u? U equal to u cube equal to u equal to 2 plus x raised to 4 whole raised to 1 by 3. Therefore u raised to 5 equal to 2 plus x raised to 4 whole raised to 5 divided by 3, and hence the answer is equal to here uh, 2 plus x raised to 4 whole raised to 5 divided by 3. This is the answer of this problem. Now let us see the problem of the third case. One more problem. This is problem we have considered two problems which are come under the case first and case second. Now integration of x raised to minus 4 into 1 plus 3x square whole raised to 1 divided by 2 whole raised to 1 by 2 into dx. Comparing this with x raised to m into a plus b x raised to n whole raised to p into dx. M equal to minus 4, n equal to 2 and p equal to 1 by 2. P is not integer, so first case is not possible. M plus 1 divided by n, minus 4 plus 1 divided by 2 equal to minus 3 by 2, so is not an integer. Then p plus m plus 1 divided by n equal to 1 by 2 minus 3 by 2 equal to minus 2 by 2 equal to minus 4. So we have an integer. Okay. Then in such a type of integration, let us put what is substitution, x equal to 1 divided by t. If x equal to 1 by t, therefore dx equal to minus 1 divided by t square into dt. Let us put therefore x raised to minus 4 into 1 plus 3x square whole raised to 1 by 2 into dx equal to 1 divided by x raised to minus 4 means 1 by 4, 1 divided by x raised to 4. So this gives us t raised to 4 into 1 plus 3 divided by t square whole raised to 1 by 2 into dx minus 1 divided by t square into dt equal to integration of t raised to 4 into t square plus 3 divided by t square, here 1 by 2, right? So this 1 by 2 gives us t into minus 1 divided by t square into dt. So you can see that this t and this t square, t cube, 1 t will be cancelled, 3 t will be cancelled, and we have minus integration of t into t square plus 3 whole raised to 1 by 2 into dt. Okay, then let us put t square plus 3 equal to u square equal to u square. We put u square, then 2t into dt equal to 2u into du. 2 get cancel and we have t into dt equal to u into du. This is equal to minus integration of this is u square, so we have u square whole raised to 1 by 2 whole raised to 1 by 2 into u into du equal to, you can see two get cancel, u into u square minus integration of u square into du equal to minus u cube divided by 3. Okay, and the final answer we have this u cube, means this is equal to minus 1 by 3 into u cube. U equal to, what is u equal to t square plus 3 whole raised to 1 by 2, the 1 by 2, this is u. So u cube equal to t square plus 3 whole raised to 3 by 2, hence t square plus 3 whole raised to 3 by 2. Again substituting the value of t, minus 1 by 3 into 1 divided by x square plus 3 whole raised to 3 by 2. This is our required answer. Okay, so these are the three cases which are importantly, how you can see that we step by step we have applied to approve the problems.
Hello guys, thank you for watching video.